Hi everyone! In this video we are going to build ERC-20 token MultiSender app. By the end of this video, you will have an app where the user can paste the contract address of any ERC-20 token, indicate the amount to send to each address, and indicate to whom send this token. Let's start. We will develop using Scaffold-ETH, a very helpful toolkit for creating applications on Ethereum. Let's run the following command in our terminal: npx create ETH at latest. Right now, the latest version is 0.2.2, in case you'd like to use the same version as I am. Let's name the project MultiSender token and select Hardhat as the Solidity framework. Now let's wait for the setup to finish. Okay, everything is installed. Here are the commands we need to run. First, change into the project directory and open VS Code or any code editor that you prefer. Then open a terminal and start local Ethereum network by running yarn chain. Next, deploy the smart contracts by running yarn deploy. Finally, use yarn start to launch the frontend. Here's our initial starting page. There are many ways to implement a MultiSender, but we will keep it simple and build it using a basic smart contract. Probably I will record another video with a different approach. Let's go back to VS Code. Packages, Hardhat, contracts, and here we already have a yourcontract.sol, which we can delete. Let's create our MultiSender contract. MultiSender. Pragma Solidity. Set the version 0.8.20 and the license is MIT. Since we are sending ERC-20 in this tutorial, let's create a minimal ERC-20 interface. This interface includes the transfer from function, which is defined in the ERC-20 standard. The transfer from function allows a token to be transferred from one account to another and returns true if the transfer was successful. Now, let's create a contract called MultiSender with a function named multisend ERC-20. And this function will take the address of the token, an array of recipient address, and an array of token amounts to send to each recipient. We will also use the call_data keyword for the arrays. This is a gas optimization as call_data stores the data in read-only memory. We will mark this function as external, so it can be called from outside the contract. Inside the function, first we add a validation to ensure that the recipients and amounts arrays have the same length. Then we are creating a reference to an existing ERC-20 token contract. Then we use a for loop to iterate over all recipients and execute the actual token transfer from the sender to each recipient. We also need tokens just to test, so let's create a contract called dApp token. We need to also set the license and Solidity version. We need to import OpenZeppelin ERC-20 contract. This gives our token all the standard ERC-20 functionality like transfer, approve, transfer from, and balance of. The constructor takes one parameter, recipient, the address that will receive the initial token supply when contract is deployed. Here we will provide a name for the token, dApp token, set symbol or short ticket dApp. Inside the constructor, we call mint to create 10,000 tokens and assign them to the recipient. We use 10 power of decimals to correctly account for the decimal places. By default, ERC-20 tokens use 18 decimals, so this line effectively means 10,000 multiplied by 10 power of 18. Base unit, also known as way in the context of tokens. This ensures that the recipient starts with a full supply of tokens once contract is deployed. Now let's move on to deployment script. Let's change from your contract to dApp token, and in the argument we need to indicate the address from the frontend as the recipient for the test tokens. Then let's deploy another script, which is a MultiSender without any arguments. Now let's delete this. We can comment this and let's remove this. Now we have a deploy script which we can run with yarn deploy. Now let's start with the front end. Next.js package app page.tsx. So we can delete some of this, for example this. Okay, let's delete it. We can keep the second line, but let's delete the first one and rename it to MultiSender. Let's remove the whole this div. Let's create a div and let's define flex grow, allows the div to expand and fill the available space inside the flex container, full width and margin top a bit. Inside the container we add another div with the class flex justify center. This centers its child horizontally. Finally, inside the center div we render MultiSender form component. This is where the user will input the token address, recipient address, and token amounts. Let's remove a couple of things. Let's now build the MultiSender form component, which is a main form used to input the token address and recipient address and the token amounts. Let's create a file for it, MultiSender form.tsx. Now let's define our component, MultiSender form. We create 3 pieces of state using useState. Token address stores the address of the ERC-20 token. Amount stores the amount of tokens to send to each address. Addresses, an array of recipient addresses, starts with one empty string. Then we define helper functions to update each piece of state. Update token address, update amount, update addresses. These functions receive new values and update the state accordingly. We will pass them down to child components. Inside the return, we structure the form using a div with Tailwind classes. Now let's import this component in the page.tsx. Let's go back to the file and import it. Inside the container, we render the token input component and pass in the current token address and amount values, the update functions to handle changes. Also, we render recipient inputs component, passing the addresses and an array the update function. Oops, and also let's fix this to the array of strings. And now let's create a new file which is called token and recipient inputs.tsx. I don't want to focus on the front-end component and would like to focus on Web3 more in this video. I will not explain how these components are written. I will leave the link for this file in the comments, so you can just copy paste it into the file token and recipients input.tsx. Right now, let's use the components token input and recipient input. Let's import it. And here how it looks. So let's go to the debug contracts page, where we can copy dApp token and paste it here. For the amount per recipient, let's indicate 10, for example. And for the copy address, we can add more recipients if we need it. And we can also delete it. Here how these components work. Now let's focus on the last component, which is actions button. Let's pass here token address, amount. Let's convert it also to the number, or pass 0. And we also need to pass the recipient addresses. This component will handle the actual token approval and multi-send transaction. So let's create a file for it. Let's create an interface, action button props. It will have an amount, number, token address, string, and recipient addresses as an array of strings. Let's define the component, action buttons. And inside the components, we need to use account hook to get the connected address. This retrieves the connected wallet address of the user. Then we need to filter the input addresses using isAddress to get only valid Ethereum addresses. We will filter recipient addresses and check if it is a valid address. Then we calculate the total amount of tokens to send. We just need to multiply amount by the valid recipient addresses. And also we need to convert the total to way using parse here. And let's import user account from wagmi. And this we will import from viem. Now let's load the MultiSender contract using use scaffold contract hook. Scaffold contract, where we just need to indicate the contract name, which is MultiSender. In the next step, we need to read allowance and token balance. So let's use read contract hook to check the allowance, which is how many tokens the MultiSender contract is allowed to spend on behalf of the user. We need to indicate address, token address, API, we can import just ERC-20 default API. Let's import the address from viem and also the same for the ERC-20 API. Next, we need to indicate function name, which is allowance, and provide arguments. Also, we need to have a query to make sure that it only runs when inputs are valid. In our case, it's connected address and token address. Now let's move on to the next, which is balance of. So we would like to know the user's token balance. We basically need to do the same thing as we did for the allowance. Now let's define two write contract hooks. The first one will be write token async for calling approve on the ERC-20 token. So we will be able to allow the contract to send the tokens. And we will use write contract from the wagmi. Now let's define write MultiSender async. So we will be able to call multisend ERC-20 on the MultiSender contract. In this case, we are going to use scaffold write contract hook. Also, we need is pending to check if the transaction is mining. Now let's create another two variables, which will help to understand if the button should be disabled or enabled. These variables are dependent on the is pending. Now let's create handlers for approve and send. Firstly, we will create handle approve token. This function is called when the user clicks approve tokens. It checks if a wallet is connected first, calls the approve method on the ERC-20 token contract, giving the permission to MultiSender. And lastly, we need to show a notification and refresh the allowance value. In case of the error, we just need to console log it and send a notification. Now let's create for the handle send token function. This function is called when the user clicks send tokens. It also will check if a wallet is connected. And then the only thing is that we need to prepare amount array, same amount for each recipient. Now let's call MultiSend ERC-20 on the MultiSender contract. We need to pass the function name, also pass the proper arguments. And also finally we need to refresh the token balance and allowance. We don't need to send the notification here because it's handled by use Scaffold-ETH hook. And also for the catch. Now let's go to the rendering part. Firstly, we need to indicate the div with the Tailwind styles. Some padding, border. Now we need to show the connected user's token balance formatted using formatted here. Then we render one of two buttons. If allowance is too low from what we need, we will show the approved token button. If already approved, show a send token button. Each button includes a loading spinner while the transaction is pending and a disabled state if the transaction is processing. Here's our approved token button. And now we need to do exactly the same for the send token. Now let's import this actions buttons component to our MultiSender form, format the file, and let's go back to our frontend. Here's our frontend. Firstly, we need to get some gas. Let's get it from our faucet. Let me get the dApp token, our test token contract address. So let me paste it here and let's indicate the amount 100 and we can send it even to the contract itself. Here I'm indicating and let me send it to myself as well. I need to approve the tokens, so token approved successfully and send it. Here it is. We can see that the token amount decreased by 300 because I sent 100 myself. And that's it. Thank you very much for your time.